Let's read the question. Magnetic moment of Mn2 plus ion is. We are given with atomic number of Mn, which is 25. So student, first of all, I'm writing the formula to calculate magnetic moment. Magnetic moment is equals to under root n plus 2 bm. And here n means number of unpaired electrons. So first of all, we have to calculate number of unpaired electrons in Mn2 plus. Here Mn2 plus argon, this is 3d5, and these 5 electrons are unpaired. That means the value of n is 5. So we can calculate magnetic moment, which is equals to 5 plus 2, which is equals to 7 under root, that means under root 35 bm. Bm is Bohr's magneton. So student, the correct answer is option number 4. Moving to next question, students, which is question number 52. Let's read the question, students. The number of mole of K2Cr2O7 required to oxidize 0.2 mole of H2S in acidic medium is. So student, first of all, for this question we need to know that K2Cr2O7 changes to Cr3 plus. That means here chromium is in +6 oxidation state, it changes to +3 oxidation state. And here H2S, sulfur is in -2 oxidation state, it changes to S. Since oxidation of H2S takes place and K2Cr2O7 is the oxidizing agent. And also for this question we need to know that the number of equivalents of K2Cr2O7 is equals to equivalence of H2S. Here equivalence of K2Cr2O7 is equals to moles of K2Cr2O7 into 6, because the change here is of 6. N factor is 6. Here equivalence of H2S is equals to number of moles of H2S, which is already given, 0.2 multiplied by N factor. N factor here is 2. So student, we can calculate moles of K2Cr2O7, which is equals to 0.2 into 2 upon 6, which is equals to 1 upon 15, ultimately equals to 0.067 mole. That means the correct answer is option number 2. So answer is option number 2. Moving to next question, students, which is question number 53. Let's read the question. Pair of elements which show +3 oxidation state only. Option number 1, thorium, actinium. Option number 2, actinium, neptunium. Option number 3, americium, curium. Option number 4, californium, nobelium. So student, I'm writing the oxidation state of the given elements here. AC, CF and NO show only +3 oxidation state. Thorium, that is TH, shows only +4 oxidation state, and neptunium show +3, +4, +5, +6 and +7 oxidation state. That means the pair of element which shows only +3 oxidation state is californium and nobelium. So the correct answer is option number 4. Moving to next question, students, which is question number 54. Let's read the question. Pair of ions having equal number of unpaired electrons present in f orbital is. So student, here we are given with Ce3 plus, Tm2 plus, Eu2 plus, Yb2 plus, Sm2 plus, Tm2 plus, and last Yb2 plus and Ce3 plus. So student, I'm solving this question. In option number 1, Tm2 plus and Ce3 plus, the electronic configuration is xenon 4f13. Here it is xenon 4f1. So in both the cases, number of unpaired electron is equals to 1. Here also it is number of unpaired electron is 1. That means the correct answer is option number 1. So answer is option 1. Moving to next question, students, which is question number 55. Select the incorrect statement among the following. Students, in this question we are given with 4 statements and we have to identify the incorrect one. So let's read the statements. Let's read number 1. All the lanthanoids are silvery white, soft metals and tarnish rapidly in air. Students, this is the correct statement. Moving to next. Many trivalent lanthanoid ions are colored both in solid state as well as in the aqueous solution. Student, this is also a correct statement. Moving to next. Mish metal contains around 95% lanthanoid metal and around 5% phosphorus. Student, this is an incorrect statement as we know that mish metal contains around 95% lanthanoid metal and around 5% of iron and traces of sulfur, carbon, calcium and aluminium. Moving to the last, photographic industry relies on the special light sensitive properties of AGBR. Student, this is also a correct statement. That means the correct answer for this question is option number 3. Moving to next question, students.